In this next example, we're going to incorporate really all of our different transformations for a tangent. You're going to see vertical shifts and amplitude, reflection, period, phase shift, and then we're going to use all that to find our 5 key points and plot the graph. Okay. So remember, the process is really the same as it was for the sine and cosine. The only main difference is that the period is going to, instead of be 2 pi over b, it's going to be just simply pi over b. And the 5 key points, instead of starting at 0 and going to 2 pi for a period or whatever the period is, it's going to sort of straddle halfway across the y-axis, okay, and then be shifted. So those are the 2 main differences in the the setup. Once we start sketching the graph is quite a bit different. It's got the asymptotes and stuff like that. So okay, so let's just sort of analyze these different features, and then we'll get into the graph after that. So the vertical shift, first of all, is always a number that's being added or subtracted outside of the tangent. And so in this case, it's the 1. Here we have a 1 being added to the tangent. So a vertical shift in this case is 1. The amplitude, remember, is the absolute value of the multiplier to the tangent. Okay, so in this case, the absolute value of the -2, or simply 2. Okay, and again, the amplitude being the value of the graph that's halfway between an x-intercept and a vertical asymptote. Okay, so that's our amplitude. The reflection, well, a reflection occurs, that's our vertical or x-axis reflection, occurs when there's a negative a value or a negative multiplier to the tangent. So in this case, yes, there is a reflection, and it is a vertical reflection. Okay, and then it means it flips across the x-axis. The period in this case, well, remember, to get the period and the phase shift, we first have to factor the argument, just like we did with sine and cosine. So to factor this, I would pull out the coefficient of x, which is 1/2. When you pull out 1/2, you essentially multiply by the reciprocal to get the other number. So if you took pi over 4 and multiplied by the reciprocal, which is 2 over 1, same as dividing by that coefficient, you'll end up with pi over 2, right? The 2 and the 4 cancel. And you can always check yourself by redistributing 1/2 times x is half x, 1/2 times pi over 2, the 2's multiplying, give you pi over 4. Okay, so it does multiply back out or distribute. So that tells us that the period is pi over b, which is 1/2. Okay, well, if you divide by a fraction, again, it's like multiplying by its reciprocal, so it's pi times 2 over 1, or simply 2 pi. So our period now is 2 pi. That means we're going to go pi on either side of the y-axis. And then we're going to need to work with the phase shift. So let's just keep that on hold for a moment. The phase shift then is going to be pi over 2, and it's going to be pi over 2 to the right because you're subtracting pi over 2. Remember, it's the opposite sign of what's in here. If it's x minus a number, that number is where the phase shift is. So here the number we're subtracting is positive, meaning it's going to the right. So the phase shift is right pi over 2. All right, so that gives us sort of a framework. Now we've got to get our 5 key points. So what I'm going to do, instead of starting at the y-axis and going half the period to the left, half the period to the right, we're going to start at pi over 2 and go half the period to the left, half the period to the right. So the 5 key points, I'm going to sketch them here. We start at pi over 2, that's our center point. Then you go half the period to the left and half the period to the right. Okay, so the period was 2 pi. So that means we've got to add pi and subtract pi. Well, if you take pi over 2, that's half of pi, and add 1 pi, you get pi and a half, or 3 pi over 2. Okay, so 3 pi over 2. Okay, think of it as having half of a blueberry pie and then adding another whole blueberry pie, you get 1.5 blueberry pies, or 3 halves, right? Okay, bad joke, but it works. Here you're subtracting a pi. If you take half pi, subtract pi, or half of something and subtract one whole thing, you get negative 1/2. So it's negative pi over 2 is our other endpoint. Okay, so that should give us a pretty good idea of our endpoints, the starting point, ending point, and the midpoint, but now we still get our quarter points. And our quarter points are found, we've done this before with sine and cosine where we average. You could, some people would divide this by 4 and add it to the endpoint. We did that also with the sine and cosine. With this one, because 0 is not really included here, I would just take the average. The average of negative pi over 2 and pi over 2 is 0, because when you average, you add them together and divide by 2. Well, add them together, you get 0. Divide by 2, you still get 0. So that one's 0. And then the average for pi over 2 and 3 pi over 2, if you add those together, you get 4 pi over 2, which is 2 pi. And when you cut that in half, you get pi, which makes sense, right? Between 1/2 and 3 halves is 2 halves. Okay, so those are our 5 key points. These are the points I want to plot on my graph. I'm noticing right now 0 is on the left a little bit, so there's not as much to the left of 0. So I've already got these drawn out. I really don't need so much to the left. So let's go with the scale of pi over 2. That makes life a lot easier. So we got pi over 2, we've got pi, we've got 3 pi over 2, and then on the left here we're going to have negative pi over 2. Okay, so there's my x-axis scale. I know that when I plot this out on the 5 key points, the 2 on the ends are going to be my vertical asymptotes. So I can sketch those in. And then the point in the middle is going to be the x-intercept. Okay, so that's just, again, the normal period just shifted over. After that, the points that are halfway in between, which would be the 0 point and the pi, the height of those are going to be, well, they would be at the amplitude, except now we have a vertical shift in as well. So I didn't even think about that when I put this point in. The vertical shift actually makes the intercept rise up 1. So let's put 1 here, 2 here, 3, maybe I'll throw 4 in as well. And then -1, -2, -3, and -4. So instead of having an x-intercept there, we don't. We really want that to be up 1 unit. So I'm going to sketch just a little horizontal line there. That's really the axis, the midway axis of our graph. So I want my intercept instead to be sort of an axis intercept, kind of interesting. So the vertical shift applies to the x-axis, or the x-intercept, I should say. Our amplitude from there is 2. Okay, so we go up 2 and down 2 at our midway points here. However, the problem with that is we also have this vertical reflection. Now remember, if our normal graph, just the regular tangent, goes up to the right like this, then the reflection is going to go down to the right, okay? If you flip that thing over the x-axis. So because we have this reflection, our graph actually starts high, comes down to that intercept, and then goes down to the right. And so we need to, for our amplitude on the left, instead of going down 2, we actually have to go up 2. So from 1 we go up 2 and we hit 3. So actually 3 is going to be our y-intercept now. And at pi, we would go down 2 from that axis, the middle axis, so 1, 2 would be at -1. Interesting. I'm going to go ahead and label these points now. So this first one here on the left is at 0, 3. This one down here on the right is going to be at pi, -1. And then I'm going to sketch the graph through those. So starting here at the intercept, I'm going to swipe that up and to the left. Ooh, wasn't a great graph, but good enough. And then we'll have to swipe it down and to the right. Okay, that'll work. Not too bad. Okay. So you can see now where that graph is. So I've got more of it drawn below because it shifted up. So you don't see quite as much of the top part of it, which just means at the bottom here it gets closer to the asymptote than it would over here. If I had more room, I would think they go up higher and closer to the asymptote. So not too bad. It's not a perfect graph, but often they won't be if you're plotting these by hand. Okay, so but again, you can see now all of these different features of the graph. You can see the vertical shift, where we shifted the x-axis up 1, along with every point really. The amplitude, so from that 1 you go up 2 and down 2 to get your halfway points. The period is 2 pi. Well, of course, from -pi/2, -1/2, up to 3/2 pi, you get a total distance of 2 pi. And the phase shift is right pi/2. So the center point, instead of being at 0, goes over to pi/2 to the right. Okay. So that should give us all the information we need. It's a pretty good graph. If we needed, again, to plot more than one period, I would just continue to add half a pi. So the next spot would be 2 pi, then 5/2 pi, and then 3 pi, and then 7/2, and so forth. Okay, or going to the left, you'd have -pi, -3/2 pi, and so forth. Okay. Other than that, I think that gives us a pretty good idea. So we'll move on in the next couple of videos to working with the cotangent.